So if I graph this function, this went to the right 2. So that means your vertex is right here at 2, and this is your graph. So that's this side, and this is the other side. Okay, so that is your graph. Let's go ahead and get the inverse. So I'm going to switch x and y. And you'll take the square root of both sides. So that cancels out. You're left with the square root of x equals y minus 2. And then you add 2 to both sides. So that means your inverse, the inverse is the square root of x plus 2. So guys, what's the transformation on the square root function? Up 2. So if I were to graph that, your vertex is right here, it went up 2. And I'm actually going to plot these points perfectly. So if I put in a 0, I get 2, right? If I plug in a 4, if I plug in a 4 right here, what's the square root of 4? Plus 2. So I get 4. So that point is right here. And let's plug in a 9. Let's plug in a 9. What's the square root of 9? Plus 2 is 5. So 9, 5 is right here. And it looks like that. All right, so guys, notice whenever you draw an inverse, it should be reflecting across this diagonal line, right? Does that look like a mirror image to you?
I think you're still wrong.
What's okay? My line is perfect now. That point is on the right spot. Okay, so what I was saying, this does not look like a perfect mirror image because let me highlight this for you. This side is a perfect mirror image of this side, right? But the issue is we have this over here. That's nowhere on my new graph, right? That's not a perfect mirror image. If it was a perfect mirror image, it would look like this. But we don't have that. So guys, what we have to do is, look what I'm going to do. So that I have a perfect mirror image, I'm going to get rid of this side of the graph. Now I have a mirror image. Do you guys see that? Let me highlight it for you so you can see what I'm talking about. This original function now mirrors this function. They're inverse. They reflect across that diagonal line. You guys see what I'm talking about? Okay, so I got rid of this side of my original graph. I got rid of that so that I can have a perfect inverse that's reflecting. Okay, so now we call that a restricted domain. So now since I got rid of this part, what's my domain of this quadratic? Yep, it is 2 to infinity. That's the domain. It starts right here and it goes up. That's 2 to infinity. What is the range? 0 to infinity. Perfect. And the inverse, let me write the equation real quick. We said the inverse was square root of x plus 2. Okay, that's the inverse equation. Looking at my inverse, let me highlight it for you in red so that we can distinguish it. This is the inverse that we did. Let me erase that. Oh, there it is. It's in red. What is the domain for that? It's 0 to infinity. That starts right here, 0, and it goes to infinity. What is the range? So do you guys notice how the domain and the range just switch spots for the inverse? Do you guys see that? Okay, so let's look at the notes. For domain and range of inverses, the range of the function f of x is the domain of the inverse function, and vice versa. Okay, so let's just notice that in this example. I'll highlight it for you. The domain of the original one is the range of the inverse. The range of my original graph is the domain of its inverse. Okay, they just switch. All right, so guys, let's talk about one-to-one functions. A one-to-one function is a function. I'm just going to give you the simplest definition that passes the horizontal line test. So for example, this is a function that is not one-to-one. This is the graph x squared. If you drew a horizontal line, it touches in more than one spot. So this is not one-to-one. It does not pass the horizontal line test. This is the square root graph. Is that one-to-one? Yes, because if you draw a whole bunch of horizontal lines, it only touches once. So this is one-to-one. This is a one-to-one function. So guys, can you think of another function that would also not be one-to-one? Yes, an absolute value of x, good, because that one looks like a V. And if you draw a horizontal line, it crosses more than once. So that would not be one-to-one. Is there another function that you guys can think of that is not going to be one-to-one? Negative x cubed looks like this. I want one that is not one-to-one. Good. X to the power of 4. That's also a U-shaped graph. Can you guys give me another one? X to the power of 6. That's also going to be not one-to-one because it's going to have a parabola shape, a U shape. Does that make sense, guys? So whenever you have something that is not one-to-one, you are going to have to restrict the domain, just like we did in this problem here. In this problem, we had to get rid of the other side of the graph. So whenever you have something like this that is not one-to-one, you're going to have to restrict the domain. Okay? That's what I want you to learn from this page, from this note. Okay, so let me give you an example. Let's say I have something that's not one-to-one, such as x plus 3 to the 4th power minus 6. What's the transformation here? Yep. It went to the left 3 and down 6. So that means I'm right 1, 2, 3, 4, 5, 6 right here. And it looks like this. It's going up. That's a rough sketch. Went left 3, down 6. It's a U shape because this is even. The exponent's even. Okay, so guys, let's go ahead and get the inverse of this. So we switch x and y. And what would I do? You would add 6. And then what? The 4th root. And then what? And then what? Minus 3. So this is your inverse. This is the inverse. So what's the transformation for my inverse? Left 6 and down 3. So I'm going to graph it on here. I'll do it in black this time. So I'm going to go left 6, 1, 2, 3, 4, 5, 6, down 3, right here. So your graph would look like this. Does that look like a reflection? No. So guys, what I'm going to have to do, let me draw this again. Should look like this. Okay, what I'm going to have to do is get rid of the left side of it. Now, does it look like a reflection? Yeah. So guys, whenever you have something that's not one-to-one, you're going to have to get rid of the other side. Does that make sense? So that it can be a perfect reflection, like inverses are supposed to be. Okay, so now please tell me what the domain for the original graph is. So for f of x, what is the domain? The one where I got rid of it. I want what I have now. Yes, -3 to infinity. Okay, and what's the range for this one? -6 to infinity. Okay, and for the inverse, what's the domain? -6 to infinity, and the range? -3 to infinity. Notice they're just reversed. Okay, all right, so you guys go ahead and try this whole page. There's also practice in Springboard and practice on Delta Math.